Bismillahirrahmanirrahim. In this video, I'll be solving end chapter question 2.3 from EDC book by Mr. Boylestad. This question I had solved earlier also, but there was some confusion to the students, so I'll try to clarify that. This is the question, and we have to determine two things. First of all, sketch V out. We have to sketch V out for this alternative input signal. And also we have to determine the DC voltage. So DC voltage here. Now in this question, there is some doubt, or there are some points which could create doubt. First of all, why to mark positive and negative when the input is alternating? I'll remove this. Similarly, you can see this is the negative terminal and there is a ground terminal. So here negative and ground they have shown to be same, so I'll remove this as well. No negative sign here. And the third thing, that all three resistances have the same value, so this will create confusion. I'll name them as R1, R2, R3. So now we'll work with this circuit. R1, R2, R3, remove the sign from here and remove the negative sign from here. Okay, now we'll apply the positive half cycle, and a very simple technique is that wherever for positive half cycle, we'll mark the top as positive and the bottom as negative. Now, in case of a diode, if the positive of the battery touches the positive terminal of the diode, then the diode becomes forward bias. And when the positive touches the negative terminal of the diode becomes reverse bias. Now this is true in most cases. So we'll just follow it. So the circuit will now become, this is forward bias represented by a short circuit because it is ideal diode. And this one is represented by an open circuit. Remember, we have to find this voltage. So we need to manipulate this circuit a little bit. From here, what I have done is I have pulled this down, or you can flip it here. So flip it here, and then again pull it here like this. We want to connect the two grounds. Okay, so when we connect the two grounds, connected like this, and now we can have a final circuit which should look like this. Just follow it. Positive top R2 to the negative. So positive top R2 to the negative. This is one branch. The other branch is R2 ground and R1. Sorry, R3 ground and R1. So this is R3 ground and R1. Now we are interested only in this V0. And so since the same voltage is applied here and also here, so we can just separate this and work on this. So we can work on the right hand part only, 100 volt input, and we have to find the V out. So by voltage division rule, the total voltage applied by the total resistance, which is R3 over R1, multiplied by the voltage across which we need to find, or the resistance across which we want to find the voltage. So multiplied by R3. And putting now the values, since these are same, 2.2, 2.2, 2.2, output voltage will be 50 volts. And so the plot will be like this, 50 volt positive. So this is for the first half. And now we'll apply the second half, negative 100 volt mark the polarity accordingly, negative at the top and positive at the bottom now. And following the same technique, that wherever the negative touches the negative of the diode, that diode will be forward biased. And the other one where the negative touches the positive of the diode, that will become reverse bias or open circuit. So this way we have drawn. And here also now we'll do some manipulation. We can just connect these points because they're all same. So we have come here, R1, and then this right circuit, we have drawn it like this. Now remember, we are going to find this voltage. So redraw it again, just like we did in the previous case. This is our positive line. From positive line, we have R1 and ground, R1 and ground. And then we have R2, R3, R2 and R3 and ground. And now we are only interested in this part. So the V out from here will be 100 volt divided by these two resistances, R2, R3, and multiplied by R3. And putting in the values, it will be 50 volt. And this is now 50 volt positive, remember. So we'll draw it like this. If you have any doubt as to why this should be positive, look at this circuit and the current flowing. The current is flowing from top. So positive here, negative here, positive here, negative here. So we are interested in this voltage. So positive at the top. Therefore, it will be positive 50 volt. So finally, remember that we had to do two things: sketch and determine the DC. So the sketch will be, this is the first half and the second half. So the total will be the sum of the two. And the last part is the find the DC voltage. So this is the formula for the DC voltage for full wave rectifier, 0.637 into V max. So putting in the value 0.63 and 50. So 31.8 volt will be the DC voltage. I hope now it's easy for you to follow. Please let me know through your comments. Thank you.